begin the webinar today. Again, my name is Betsy Seibel, and I'm with Teledyne Techmar. And today's webinar will be on recovering VOCs from difficult soil matrices, comparing various extraction techniques. And today our presenter is Ann Urich, who's our applications chemist here at Techmar. And with that, I'd like to hand it over to Ann. Oh, I'm sorry, one more thing. Just a few housekeeping notes. If you are listening over the phone, please put your phone on *6 to mute it so there's no interferences or disruptions between the call. And the webinar will be available afterward. We'll have it posted on our website, and we'll send you a link to that so you can listen if you need to at a later point in time. Okay, here's Ann.
Hello, my name is Ann Urich. I'm an applications chemist at Techmar. I performed the Purge and Trap portion of this webinar research, and Roger Bardsley did the Headspace analysis. Again, this is recovering VOCs from difficult soil matrices, and this is comparing different extraction techniques via Headspace and/or Purge and Trap. The soil matrices that we looked at for this study are sand, clay, and humic soil, or an extremely absorbent soil. The analysis techniques, again, were Purge and Trap and Headspace analysis. We did low-level VOC analysis, in which there is an in-vial purge, and we also did high-level VOC analysis, which is base solvent extraction. For Headspace analysis, we did static Headspace, or closed loop, and dynamic Headspace, which is a continuous. I would like to briefly go over what Headspace and Purge and Trap analysis are. For Purge and Trap analysis, first of all, you take a measure amount of sample and you place it in a sealed vessel. The sample is purged with an inert gas, and the gas causes the VOCs to be purged out of the sample and retained on an analytical trap. The trap is heated, and the organic compounds are sucked onto the GC by backflushing the trap with the inert gas. The inert gas that I used for this study was a nitrogen gas. I will briefly go over a simple Purge and Trap flow diagram. The Atomx, which we used for this study, we have flow diagrams for that also, but they are a little confusing, so I'd like to start with a simple flow diagram. For Purge and Trap, if you look at the pointer, the sample is purged in the Sparger vessel, or in the case of low-level VOC analysis, it's actually purged in the vial. You're purging with an inert gas, and then the volatiles go out of the matrix and they get absorbed onto an analytical trap. The analytical trap will collect all the volatile organic compounds, and then after the set 11-minute purge time, the trap is heated, and the analytes are backflushed over to the GC through a heated transfer line, and this is where they will be analyzed. For low-level VOC analysis, we use the in-vial purge. The concentration range for this is 1 to 200 ppb. For the high concentration soil analysis, the concentrations are greater than 200 ppb, and it is necessary to do a solvent extraction. It's important to note that with solvent extraction, although the concentrations are greater than 200 ppb, it is a dilution, so the curve range is still 1 to 200 ppb. It's just a factor of 100 because it's a dilution. For low concentration soil analysis, you collect a 5-gram sample. The sample is placed in the 40 milliliter vial, and the vial will have a stir bar already in it. The vial is sealed and placed into the autosampler for analysis. The autosampler will add deionized water, surrogates, internal standards, and then the sample is purged with an inert gas in the vial for the VOC analysis. One of the things to note are that your surrogates are used to monitor your sampling conditions and to see if there's any matrix interferences that cause your analyte and or surrogates not to be recovered properly. For your internal standards, that is used to monitor your instrument conditions and make sure your instrument is working properly. Here is the Atomx flow diagram, and as I said, it's a little confusing. I just want to highlight a couple of things. Here's where your sample is, and it is stirred and purged in the vial. and then the analytes are collected through the needle over through a transfer line over onto the adsorbent traps, and then the traps are back flushed over onto the GC through a heated transfer line. For the high concentration soil analysis, again your sample and stir bar are placed in the vial, only this time you're adding an aliquot of solvent. In this case we use 10 mils of Purge and trap grade methanol. One thing to note is when you're doing a full list of 8260 compounds, as we did for this study, your analytes range from light compounds, gas compounds, as in vinyl chlorides, down to your trichlorobenzenes and your naphthalates. Because they have different coefficients of diffusion into the solvent, you have to let the sample sit in the solvent and extract for several hours before you actually stir the sample and take an aliquot of the extract. This is just to ensure that all of your analytes diffuse into the extract properly and you get a good recovery. The sample and solvent are then stirred for a prescribed amount of time on the Atomx, in this case. Then the sample is allowed to settle, and an aliquot of the extract is taken and added to 5 mils of DI water, and it's purged for VOC analysis. In this case, I used 100 microliters, and it ended up being a 100X solution. Here is the methanol extraction flow diagram, and again, I'd like to just highlight a couple of things. Your sample is over here, and your extract is already in it. It's stirred on the Atomx and allowed to settle. The needle will then be submerged into the extract and pulled over to the syringe. The syringe will then push the extract over towards the Sparge vessel over here. As the extract is in the lines, in order to ensure the complete extract gets pushed over to the Sparge vessel, the deionized water is then pulled into the syringe along with your internal standards or surrogates or any kind of addition you want to add. Then it's the internal standard surrogates and the deionized waters is pushed over to the Sparge vessel, and this will also rinse any lines and any extract left in the lines over to the Sparge vessel in order to ensure your entire extract gets over to the Sparge vessel for purging. The sample is purged on the Sparge vessel, and the analytes again are collected on the analytical trap and back flushed through the transfer line over to the GC. The simple diagram of Headspace. In this case, the soil is placed in the Headspace vial, and we found that at the addition of 5 mils of deionized water into the soil, matrix aided in the analytes better diffusing into the Headspace. So the deionized water is one thing that we would recommend with a soil analysis. In this case, time and heat, the sample is loaded into the platen, and it's heated and mixed, and this causes the analytes to go out into Headspace, and they eventually reach equilibrium. And so you have half of them in the Headspace and half of them matrix. And then the Headspace is actually swept into a loop in the case of static Headspace. In the case of dynamic, there's a constant sweep, so the analytes never actually reach equilibrium. So you pull more analytes over, and they're swept onto an analytical trap. So this actually enables better sensitivity. That's why the dynamic mode is called continuous sweep. Again, the two types of Headspace analysis we did, we will discuss our static or closed loop or our dynamic continuous sweep. I will briefly go over the steps for the static and dynamic Headspace analysis now. In this case, the sample is placed in the vial is sealed, and you put the vial in the auto sampler. It's then loaded in the platen for heating and mixing, and then after you're done with your prescribed heating and mixing, the mass flow controller records static vial pressure, and then it pressurizes the system, the sample, to a set point, and then it's vented through the sample loop, and the sample loop is placed in line with the GC and sent over there for analysis. Here's a flow diagram of static Headspace. As you can see here, the vial is placed. The vial has already been heated. It's on the needle, and the needle is pressurized, and the sample goes over through the loop, and the excess sample is vented through the vent. Once the loop is filled for a prescribed amount of time, It closes the loop system and actuates the 8-port valve, and the sample is sent from the loop over to the GC for analysis. For dynamic headspace, again, the sample is placed in the vial is sealed and delivered to the auto sampler, and then it's loaded to the spaten for heating and mixing. But in this case, the headspace is continuously swept, and the sample is collected on the sorbent trap, and the trap is heated and back flushed onto the GC. Here is the flow diagram for dynamic. As you can see, as it's sweeping the headspace, you have the gas coming from the mass flow controller, and it sweeps the headspace out for a prescribed flow and a time that you set within the system, and then it goes over and it's trapped onto the adsorbent trap. The excess gas is vented, and then once you're done with your sweep, the trap is heated and the sample is back flushed through the 8-port valve and over to the GC as the 8-port is actuated. For the GCMS, we used an Agilent 7890 GC and 5975 mass spec. We used a 30-meter J&W Scientific DRX column. The other program was from 35 to 210 with a 14-minute run time. The column flow we used was 1.2 mils a minute with an 81 split. The scan range was 35 to 300 with a threshold of 400 and a scan rate of 5.19 scans per second. For the curve preparation, we used a 50 parts per million stock standard of the VOC mix. The low-level curve range was 1 to 200 ppb. The high-level flow curve range was 1 to 200 ppb also, but keep in mind this is analyzing a 100x dilution, so the actual sample concentration range is actually 100 to 2 ppm, 100 ppb to 2 ppm, sorry. Static headspace curve range was 50 ppb to 2 ppm. Sensitivity is not near as good with static, so 50 ppb was the lowest we could actually see the analytes. For dynamic headspace, on the other hand, the range was 5 ppb to 200 ppb as it is much more sensitive. So the sample prep, low-level cell analysis, the sample and the filter are replaced in the 40 ml vial and spiked with the VOC standard. The Atomx added the 10 mils of deionized water and the internal standard, and Purge and trap was done on the Atomx. For the high-level cell analysis, the soil sample and pill stir bar were placed in the 40 ml vial again, and the sample was spiked with the VOC standard. But in this case, we added an aliquot of the methanol and let the methanol and the sample extract for a few hours before placing the sample on the Atomx. Once the sample was placed on the Atomx, the sample was stirred, the soil methanol mixture was stirred, and then allowed to settle, and the aliquot of the solvent extract was drawn out of the vial along with the internal standard and deionized water, and they were sent over to the Sparger vessel where Purge and trap was done by the Atomx. Headspace sample prep was the same for static and dynamic headspace. The soil sample was placed in a 22 ml headspace vial and spiked with the VOC standard, and it was also spiked with the internal standard, and then deionized water was added. It was 5 mils of deionized water added to each sample. The sample was then placed on the auto sampler of the HT3, and the static and or dynamic headspace was done on the sample. There are different tweaks and foibles with the samples as the matrices changed that I will highlight as far as sample prep was. The sand matrix, there were a couple advantages and a couple disadvantages. The advantages were the VOC compounds extracted very well in methanol, and the VOC compounds actually select very well into headspace when the deionized water was added to the sample. We did try sweeping the VOC compounds into the headspace on dry sand and dry clay and soil, but we found issues as far as getting the full amount of sample into headspace, as the gassy compounds tended to absorb into the sand, and the chromatography was not very good. So we added deionized water to all the soil matrices in order to accommodate this. The disadvantages for the sand matrix are the polar compounds really affected the low-level purge and trap results, and the static and dynamic headspace sand matrix. We had issues with polar compounds also. Just as recoveries weren't quite where they should have been, and it was only the polar compounds. There was an interaction within the sand matrix that caused an issue. We did not see this issue with the methanol extract. There was no matrix issues with the extraction. And again, the VOC soaked into the sand matrix, and it was necessary to deionize water. For the low-level VOCs in the sand matrix, I'm going to highlight several parameters that we changed for each analysis for each matrix. I'll briefly go over these parameters for each type of matrix and each type of analysis. For one, with the low-level VOC sands, we added 10 mils of water, and the purge mix speed was medium. We used a methanol needle rinse of 3 mils with a half-minute sweep time. The thing to note with the needle rinse is the Atomx has this ability to rinse the needle with methanol, which really aids in reducing your carryover as it rinses the needle and any analytes that are stuck within the system and the transfer line. It really depletes carryover and does a very, very good job with any kind of system contamination. For the high-level VOCs, we did a mix speed of medium, sample mix time and a settle time of 1 minute. This is pretty standard with sands, and it works very, very well. Different matrices require different mix times and settle times. So this was changed depending on the matrix. Again, we used the needle rinse and the sweep needle times, but this also we used the methanol glass rinse. And it's important to note with extractions you're using highly contaminated soils. So your sample lines are going to have really highly concentrated extracts go through them. So this glass rinse and this needle rinse really rinses your lines really well with the methanol, and you don't have the carryover issues. Static headspace, we had a platinum temperature of 85 degrees with a 30-minute equilibration time, and the mixer was on. The mixing time was 5 minutes, level was 5, and it was pressurized to 10 psi, and the loop flow pressure was 5 psi. Again, you can change different parameters. We worked with the mixing time and the mixing level as far as the different matrices. Changed that in order to help get extract the VOCs out of the matrix. For dynamic headspace, we used a flattened sample temperature of 65 degrees Celsius. This was in order to accommodate water issues and to keep down our dry purge time and try to limit our cycle time. So we had a 2-minute dry purge time. If you increase the flattened sample temperature, especially when you're dealing with water, you really do need to increase your dry purge time in order to eliminate water. We had a preheat mixing level of 5 with a 5-minute mixing time, and the sweep flow was 75 mils a minute with a sweep flow of flow time of 6 minutes. And this, again, is changed depending on your matrix. Now I'm going to show you some sample results. For the low VOC sand, we saw an issue with the polar compounds. Again, your ketones and your acetates, you had actually higher recovery than you should have because of the interaction with the matrix. As you can see here, if you look at the chromatography, you can see a couple of the compounds here where the recovery for the VOC extraction, which is in red, is higher than the calibration standard, which is in blue. This only happened with the sand matrix, but it was an issue with the low VOC purge and trap. You only saw it with the polar compounds. The recoveries for the gases and the heavier compounds was consistent with where it was spiked at. Now with the sand matrix with the extraction, you can look at the results. They are almost complete overlays. The recoveries are really good. The calibration and VOC extraction results laid very well on top of each other, and the recoveries were right where they should be as far as what they were supposed to get. For the static headspace, again, you see the problem with the polar compounds where you see some of your acetates and acrylates, but in this case, they're absorbed into the sand matrix and we don't have the recoveries. As you can see, the calibration standard here in blue, and you really have no recovery with the VOC extraction. Now again, this was only really with the polar compounds. We didn't see it with the heavier compounds or the gases, and we had really good recoveries other than the polar compounds with the static headspace. Same results were with the dynamic headspace. The sand really did have a problem with the polar compounds, and again, you can see the calibration standard higher than the extraction results for compounds. The clay matrix, we used non-toxic clay. The advantages with clay were, there were a lot of advantages with clay. We had really good success with our recoveries with clay. The VOC compounds extracted very well in methanol and with the clay matrix. They purged really well out of the clay in water, and they swept really well into the headspace without the addition of DI water. The disadvantages with clay mainly are the experiment time's longer. You have to agitate the sample, and it requires a little bit more vigorous stirring in order to get the VOC compounds out of the matrix, and a lot of times it requires a little bit of longer agitation time in order to get the VOCs out of the matrix. Here we used a 10 ml water volume, and as you can see, the purge mix speed is set to agitate. Again, we have the methanol needle rinse, and it's 3 mL at a half minute. There is not a longer agitation time with the low-level VOC analysis as it's agitated as you're purging it. High-level VOCs in the clay matrix, you can see that the sample mix speed is set to agitate again, but the mix time, instead of being 2 minutes as it was for the sand, is 5 minutes. And the settle time, again, is only 1 minute as clay does settle out very easily. Again, we have the needle rinse and the glass rinse in order to limit your carryover. And your sweep needle time is, again, only a half a minute as you don't have any problems with the needle getting clogged up with any of your matrix. If you do think it might be a problem, then you can sweep more methanol through your needle and you can use a longer sweep time, as you'll see we did with the humic soil. For the static headspace analysis, the platinum sample temperature was kept at 85 and the same equilibrium time and the mixer was on. But in this case, the mixing time was 10 minutes instead of 5, and the mixing level was 8 instead of 5. Again, the pressurized and loop flow pressure was the same, and that can be changed if you have a higher static pressure, but this worked really well with this system. For the dynamic headspace, the platinum temperature and dry purge time are the same, but the mixing level is at 8. We kept the 5-minute mixing time. That seems to be sufficient, but we did need a more vigorous stirring rate. Sweep flow rate and the sweep flow time were the same as it was with the sand matrix, as we did to increase that time in order to get the VOCs out of the matrix. For the results here, you can see that the calibration standard and the extraction results for the low-level VOC analysis were really right dead on. They were really no problems. We had no problems with extracting it out of the, just purging in the vial. For the solvent extracted, again, there were no matrix issues. They were really good recoveries. Everything was consistent. We just didn't really have any problems with this matrix whatsoever. And with Headspace, it was the same. It was a really nice system to extract. We really did not have any issues pulling the volatile organic compounds out of the matrix. And as you can see, we don't have any problems with the polar compounds with this matrix. Finally, with the dynamic, you see the same thing. It's really, really good recoveries. We were really pleased with it. Soil matrix, on the other hand, caused lots of problems and lots of headaches. It's very, very absorbent. The biggest advantage we saw and the best extraction method that we saw was the solvent extraction. they extracted very, very well in methanol. The biggest issue is we had to use 20 mils of methanol for the solvent extraction, as it absorbed the methanol so readily. So it was actually a higher dilution than the sand or the clay. The disadvantages are many. For one, you have longer settle times, have longer time to sweep your needle. For the in-vial purge, you also need more methanol to rinse your needle for the purge and trap. Another disadvantage is it readily absorbs water and methanol, so the same is diluted in order to perform purge and trap. In Headspace analysis, we could only fit 2.5 grams of the soil into the Headspace vial, as it was a very light, and we had density issues as far as getting any more soil in there, so we already had to start with the lower amount of soil. The matrix interfered with the purge efficiency of the heavier VOC compounds, which you will see in the results. The heavier VOC compounds did not want to purge out of the matrix very well, and only would come out if we used the methanol extraction. The heavier compounds also would not want to migrate out into the Headspace, and we had very poor recoveries for the heavier compounds with the Headspace analysis also. We also had the longer time to sweep the sample into the Headspace for the dynamic Headspace analysis. For the low-level VOCs, the water volume was 10 mils, but we only used 1 gram of soil as there were density concerns. And when you purged the sample in the vial, if you had too much soil in there, then it did not work well and did not purge out very well at all. It didn't do real well with the 1 gram, but the 5 grams, I believe. The mix speed was medium again, but in this case I used a 5 mil methanol rinse, and I swept the needle to increase any chance of having any soil get caught in any orifices. High-level VOCs, we had medium mix speed. Again, I used 20 mils of methanol for this extraction. The mix time was 2 minutes. But if you'll note, the settle time was 10 minutes because it took a long time for that light soil to settle out of the methanol in order to pull the aliquot of the extract out and for analysis. The needle rinse was on, and we increased the rinse volume from 2 mils to 3 mils for this analysis. Throw up the needle for a full minute in order to make sure we didn't have any soil clogged in any of the needle orifices. Again, we used the glass rinse with a 3 mil methanol glass rinse volume. For static Headspace, we had the 85-degree platen and the equilibration time. The main difference here is we had a 10-minute mixing time at a mixing level of 8, much like the soil, because of the fact that it was very difficult to get any of the volatile out of the matrix and into the Headspace. For the dynamic Headspace, we had, again, the 65-degree platen with a 2-minute dry purge. The mixing level was 5 for 5 minutes, but if you'll note, we had a sweep flow rate of 75 mils a minute as before, but we swept the sample for 10 minutes in order to get more of the analytes into the Headspace and onto the analytical trap and try to increase. If you look here, if you look at the calibration standard versus the VOC extraction results for low-level soils, the lighter compounds purge out and do very well with the absorbent soil. However, if you look at the heavier compounds, your recoveries are very low and get progressively lower as you get to the heavier compounds like naphthalene and trichlorobenzene. Now, if you look at the extract, you'll notice it's a 25 ppb calibration standard, and that's because we use 20 mils of methanol instead of the 10 mils of methanol, so it's actually a 200x dilution instead of a 100x dilution. But if you look at the results, they extract very, very well and very consistently and as expected when you're extracting in methanol. In fact, it really were great recoveries with the methanol extraction. We were quite pleased. Now, with the static Headspace, the recoveries are poor all around. Gases to heavier compounds, we just really did not get very good recoveries. No matter what we tried, they just did not. The volatile organic compounds did not want to go into the Headspace during static Headspace. For dynamic, we're slightly better. The lighter compounds do go into Headspace a little bit better. But as you can see, again, the heavier compounds do not want to go into the Headspace, and the recoveries are very poor, just as we saw with the in-vial purge with the low-level VOC analysis. One thing I'd like to note is that the Headspace does have the method optimization mode. And here in this mode, with the software, if you're dealing with a difficult matrix, you can change your platen temperature, your equilibration time. You can change a lot of parameters depending on if you're doing static or dynamic. You can have the instrument ramp up in increments and look at different experimental parameters and optimize your recoveries and find out what works best with your particular matrix. Trap choices for VOC analysis that would be used for purge and trap or static would be the VOCs 3000 or K-trap, VTEX, number 3 trap, or a Techmar trap. And these all contain hydrophobic absorbents that can enable you to decrease your dry purge time and is better for removing your water and reducing your sample. Summary, static Headspace proved to be a great way to determine high levels of VOC contamination in soil. Because the loop is used, you don't have as many issues with contamination. Dynamic Headspace was a great way to detect lower amounts of VOC contamination and displayed about 20 times as sensitivity as the static method. The biggest issues here is optimizing your method in order to get your VOCs into the Headspace. As you can see, the soil analysis needs some more work as far as optimizing those and trying to get more into Headspace. It's very difficult to get those out of soils. One advantage to the Headspace analyzer is it can be used if you have to do purge and trap analysis on a highly contaminated sample. You can use the static method of the Headspace analyzer in order to determine what kind of dilutions you want to do on your purge and trap, therefore you won't be contaminating your system. The purge and trap summary, the methanol extraction proved to have the least issues with matrix interference with the sand and the humic soil. However, for lower reporting limits, you would have to use larger extraction volumes. Purging the soil in vial proved to be very good with sensitivity for low-level detection of andalites, but you also have more issues with matrix interferences, so you have to kind of weigh your pros and cons there. Overall, when analyzing a really difficult soil matrix, the extraction proved to be the best choice in determining VOCs in soils, much better than Headspace or an in-vial purge. It was, as you saw, the chromatography was very good overlays between the standard and the extractions. Thank you for attending. I will take any questions if you'd like to email right now, or you can call our 800 number and ask us questions anytime. Or you can email us at techmarinfo@teledyne.com. Happy to answer any questions in the future.
For those of you on the call right now, you can either type your questions in the Q&A mode at the top of the screen or take your phone off of mute and ask your question. I'd like to thank Ann for a great presentation today and hope you all got something out of this webinar, and we'll come back for any future webinars. So we'll just wait on the phone. For those of you who don't have any questions, you're free to log off now, and those who do, we'll just wait for your questions to come over the phone or the internet.
Also, we have several application notes for the Atomx and for the H23 Headspace system. If you'd like to look them up on our website, here's a list of the Atomx application notes. They've been on your screen for a couple of minutes. And then also we have the HT3 application notes. Here's a list. I will leave this up for you to look at. And you can also go to our website and look at our application notes and see if you have downloaded some of them. I'd be happy to take any questions.